my name is Greenfield, and I'm going to be speaking about the biomechanics of head injuries in female collegiate soccer players. So the reason why I chose this project was because during my sophomore year of high school, I suffered a sports-related concussion, which ultimately put me on the sideline for about 8 to 12 months. I had gotten post-concussion syndrome, and it was a whole mess, and since then I realized that I was super interested in research and injury prevention through concussions. So what is a concussion? A concussion is also known as an MTBI, which is a mild traumatic brain injury. So as seen in figure 1 here, you can see that a concussion is a violent jarring or shaking that results in a disturbance of brain function. By disturbance in brain function, it means that the symptoms can vary from headaches, nausea, confusion, dizziness, blurred vision. There's a whole ton of different possible symptoms that you can suffer from if you have a concussion. So to dive into the biomechanics of what a sports concussion is. In the first article that I examined, they said using measurements of magnitude, direction, and type of head impacts and head motion can be used to sense a traumatic brain injury and how it can be calculated. So measuring the head movement in response to the impact. So head gets hit, how does the head react? A study was conducted by Lindsay Lamond and other colleagues from the University of Delaware in Newark, and the study is titled Linear Acceleration in Direct Head Contact Across Impact Type, Player Position, and Playing Scenario in Collegiate Women's Soccer Players. So here they examined an entire group of 23 women, which were female collegiate soccer players, and they all wore these Smart Impact Monitors, or an SIM. And it's an accelerometer, and it's used to calculate and examine the linear acceleration as a dependent variable. And the independent variables were categorized by the type of impact, whether it was head to head, head to ground, head to foot, however it happened, or ball to head, and the field position and playing scenario, so whether they were a goalie or a person playing wide mid. So there were 627 impacts that were used out of 10,270 impacts recorded. Down here you can see the calculation that was used as well. So this calculation it's a little blurry for some reason, but it's examining the linear acceleration of the head, linear acceleration of the Smart Impact Monitor, rotational acceleration of the head, and the rotational velocity of the head in an estimated distance velocity from the SIM to the head, comparing it to males. So the linear acceleration study continued to say that shots and clears, which are two of the types of impacts that were found, resulted in a higher mean linear acceleration than passes. Head-to-head impact and unintentional hits had a higher mean linear acceleration than purposeful headers, making them more dangerous. There was no difference across the positions that the players were in or the scenario of the game. So down here you can see some of the figures of the total number of shots, clears, passes, etc., as well as the calculated through the equation that I showed on the last slide, what the impact had done to the player. In this next study that I used, it was conducted at the Bioengineering Center of Wayne State University to see whether linear or angular acceleration were worse. So this examined concussion mechanisms such as from a biomechanical standpoint, looking at shear stress, distortion, mass movement, and how the brain stem reacts to everything. And it's saying that linear acceleration is the most important mechanism, while rotational acceleration and negative pressure and cavitation are of minimal or no significance. So 2 tests were used using cadavers. One was striking the head with a moving impactor or hitting it into an acrylic block. And from there they found the center of mass of the brain in the head and used that to find, with a very high frequency X-ray, to examine sagittal and coronal planes of the brain to see how the brain reacted to those impacts. So in this study, they stated that a lot of researchers say that you either have to say linear acceleration is worse or angular acceleration is worse. But their findings said that both of them were just equally as bad. And they both had different types of impacts on the brain, but they both absolutely had an impact on a concussion, as well as strain rate, which a lot of other researchers have not said. So strain rate, in summary, is a change in strain of a material over a set period of time in the space that it moves. So consider examining, some of the things I said in the article is to consider examining brain response instead of input to the brain, and injury is intimately related to the local responses of the brain and to the global input to the entire head. So that was interesting because a lot of researchers were avoiding saying that as well. So in this last study is more about injury prevention, and it was conducted through Temple University and University of Delaware, as well as Temple University Hospital. And they found gender differences in head and neck segment dynamic stabilization during head acceleration. So they found that females have higher susceptibility to suffer from a concussion, but they wanted to know why that was. And doing different measurements such as isometric contraction, testing stiffness, they were able to find out why women are more likely to suffer from an MTBI. So in this contraption here, this is what they used to study isometric contraction as well as stiffness in the neck. So they took these external force applicators and used 40 physically active participants, and they were volunteers, 20 male and 20 female, and as well as an EMG to find the muscle recruitment that were used, the activity and peak. So even though women had recruited more muscle fibers more quickly than males, they still had a lower strength. So through different anthropometric measurements such as girth and mass, they were able to come through the calculations and find their results. So in here you can see the injury prevention is continued with neck stiffness. All of these are how they measured their stiffness in the neck to find that females had 29% less stiffness than males, and that through force flexion and extension in their neck. In conclusion, it was found that strengthening neck muscles as well as reducing the number of times there's a head impact will really reduce the likelihood of a minor traumatic brain injury. So with that, here are my references for both, and I hope you learned something.